Hi everyone and welcome back to another video. We have another Voodoo2 here today, and this is the last Voodoo2 that I have from a package that I got from Germany, and I kept this card because it is the most difficult one to repair. And why? Well, let's measure the resistance on our voltage regulator. And this is a 8 megabyte card. For a card like this, we should have the following resistances. On the 5 volt line, which also connects to the memory, should be around 30 to 35 kilo ohms. On the middle pin, this is the 3.3 volt output, we should have around 300 ohms. And on the adjust pin here, the lower one should be around 200 ohms. So let's see what we get on those pins. Let's start with the adjust pin, so the lower pin. And we are getting 75 ohms. So that is not correct. This is too low. I haven't looked up the specifications, but it could be that we are getting a very wrong voltage output. Now, the problem is that the 3.3 volt line connects to our 3DFX chips. It could be that it's higher. So maybe it's 4 volts instead of 3.3, and that is bad. So I definitely will not put this card in a running system. Let's check our 3.3 volt line. This one should be 300 ohms, but we are getting 12. Okay, so that this was 12 ohms only. So this definitely is not correct. I'm sure we have a faulty capacitor here, but now I cannot plug this card in because I'm afraid of the adjust pin here, and we're sending a high voltage to our 3DFX chips. Let's check our 5.5 volt line. And here we're getting 2.8 mega ohms. So this is a reading I have never seen on a card like this before. It's not a problem, but it's way higher than what I usually read on these cards. Maybe it's because of all the other readings we get. I really don't know. But now the big question is, how do we fix this card? I do not want to plug it in, but I still want to figure out what's the problem. We know that on our 3.3 volt line, which is connected to our 3DFX chips, we have a very low resistance. In the past, I have used a hot air station to figure out which capacitor is bad, but that was mainly on the 5 volt line. On 3.3 volts, that is a little bit more difficult because usually the capacitors are smaller. So what I want to do today is I want to use voltage injection to figure out which cap is bad. And for this, I will use my bench power supply set to 1 volt. So we're below a threshold of 3.3, so this is fine. And the amps are set to 1 amp max. So we are limiting the current, that we are not blowing something up by accident. At 1 volt and 1 amp, we are still producing 1 watt of heat, so to say, and we should be able to figure it out using a thermal camera. Before we dive into this repair, a huge shout out to PCBWay for sponsoring this video. I got asked in the past how to start learning electronics. For me, it was all about hands-on experimenting, making mistakes, and building things. If you're ready to move your projects off the breadboard, PCBWay is the perfect partner. Whether you're ordering your very first prototype or a massive production run, they've got you covered. They really are a one-stop shop. You can upload your own design or grab a build from their shared project space to see how others do it. And hey, if you aren't ready to pick up a soldering iron just yet, they can even handle the assembly for you. Plus, they do way more than just boards. Think CNC machining, 3D printing, sheet metal fabrication, and injection molding. Basically, if you can dream it, they can build it. And a quick heads up, their 12th anniversary badge contest is live right now. Just get your submission in by May 10th. Check the link in the video description to get started on your next project at PCBWay.com. And now, let's continue and inject some voltage into this Voodoo2, and hopefully we'll figure out what's wrong with it. Okay, so here's my setup. This is my bench power supply. I set it to 1 volt and 1 amp as output. So maximum we can draw is 1 watt. This should be more than enough to light up any capacitor that is bad. And now I'll hook up the leads to our 3.3 volt line. So this is the resistance of 12 ohms that we have measured before. That would let the current flow through the circuit, which only has 12 ohms in resistance, and hopefully we will see if something lights up. Okay, so this is the front of the card, and let's see what happens when I power on the power supply now. So the leads are now connected to ground and the 3.3 volt line, and nothing lights up on the front of the card. Those spots that you can see, these are only reflections. This is nothing here. So we have nothing on the front of the card. So then we need to turn the card around and see if something is lighting up at the back. Okay, so yeah, we have to make sure that we are connecting our leads again to the correct terminals. So one is ground and the other one is our 3.3 watt line. These holes in the card are perfect for this. Okay, and now let's see if something lights up. Oh, did you see it? Okay, let's go a little bit closer. Yes, there is something. And here is our faulty cap. So yeah, with the resistance this low, I think this is the best method to figure out what is at fault. At 1 volt, we do not damage anything on this board. So that's a good voltage. 1 amp limit is also perfect. It doesn't get super hot, but it is good enough for a thermal camera to be picked up. Yes, you do need a thermal camera. It's the easiest way to spot this. So if the resistance would have been much higher, let's say 150 ohms or something like this, it would be hard to figure out which cap is at fault. But I think it would also be difficult for the hot air station to figure this out. So this is another method, finding faulty caps. Okay, and here is our bad cap. I already put a replacement here. This is a 100 nanofarad cap. C65 is our issue. This is the one that got hot. So let's remove this and see how our resistance is changing. So this is our bad one. And now let's put our new cap in here. There we go. Okay, let's add a little bit more solder here. There's a little bit too much solder. There we go. Okay, so now let's see what our resistance is on the 3.3 volt line. Okay, so 3.3 volts middle pin. You can see I already probed this a lot. 300 ohms. So we fixed our 3.3 volt line. Let's see what is the adjust pin now. Okay, look at this. We have 200 ohms. That's exactly what we need. That is interesting. Now I'm curious what we get on the 5 volt line. So here we're still getting mega ohms. This is odd. As far as I know, this should not be in the mega ohms. So I'm assuming the 5 volt comes directly from the PCI slot and doesn't go through any other components. So basically all the memory chips should directly get the power from this 5 volt supply line. I don't understand how it can be in the mega ohms, because one of these memory chips alone has a resistance of 1 mega ohm, and I know this because we fixed one time this Voodoo2 with the exploded memory chips, and we measured the resistance between ground and supply, and the standard resistance for those memory chips is 1 mega ohm. Now if you have multiple chips in parallel, the resistance should drop. Oh, well, there's one cap that's a problem, but there is no memory chip here, so this is not of concern, but let me just get rid of this anyway. This is for sure 100 nanofarad. Oh, this is part of the pad. Did the trays get ripped off here? No, I don't think so. I think this is okay. So let's first get this pad done. Still have mega ohm reading on the 5 volts. Oh, there's another one. So yeah, this card definitely got the bump here at the end corner. Also here, some damage. 100 nanofarads. Unfortunately, this cap is not really responsible for our 3 mega ohm reading on the main 5 volt line. I have a feeling this is okay. There is nothing else connected except maybe, I guess the RAM duct is connected to the 5 volt line as well. Maybe some other chips here, not sure. The 3DFX chips should be connected to 3.3 volts. Only the memory chips, mainly the memory chips, connect to the 5 volt line. We have a mystery to solve, and I'm sure you're curious as well. Why do I have mega ohms on this card? So I'm deciding now to remove one of the memory chips, and we will measure what the resistance is. I think I will take this one. This one here is free, easy to remove. They should have a very high resistance or impedance between the supply and the ground pin. Let's get this chip off the board. That's an experiment now. I need to let this cool down. So my previous projects, when I had a memory chip, they had 1 mega ohm across the 2 pins here. This is supply, here's supply, and here is ground. So let's see what we get when I measure this chip. And we're getting 6 mega ohms. So yes, these chips are different. And well, that confirms now that most likely the higher resistance is absolutely not an issue, but it also confirms that we have different memory chips. So you may get a different value on your Voodoo2 card if you have these type of memory chips. So the values you see on my channel sometimes are dependent on what components are soldered to those Voodoo2 cards. It doesn't mean that just because you have a higher resistance that you have a problem there. Yeah, there are 6 mega ohms. Okay, let's try the card. Card is in the system, and so far so good. Let's see if we get a multimedia device in the PCI listings. Yes, the third one. That looks good. Let's hope that it shows up and we get 8 megabytes of Voodoo2 goodness in Windows 98. And we have our Voodoo tab. Nice. Good. Okay, it detected the card and we have 4 megabytes and 4 megabytes. So 8 megabytes of Voodoo2. Nice. Let's just run 3D Mark very quickly. And here we go. Our card is working nicely. So yeah, we used voltage injection this time to find a faulty cap. If you like this, don't forget to give this video a like and comment. I'm looking forward to reading all your comments always. And if you haven't done so, please subscribe to my channel. I also opened up Patreon again, so if you want to support Bits on Bolts, head over there and pick one of the memberships. I also opened memberships here on YouTube, so if you want to support the channel, check it out. And of course, thank you so much for your support. I guess this is another Voodoo2 that can live on a good life. Of course, we have to make sure that we'll play one round of Unreal Tournament. I'll already say goodbye to you right now, and I will see you in the next video. Thank you so much for watching. Thanks for your time. Take care and bye-bye.